Hi, and thank you. So this session is going to be about one of my open source projects called go-grpc-channelz. All right, so first of all, who am I? I'm a developer at AppsFlyer. I work on all things infrastructure at AppsFlyer. I'm also known as the voice at the Reversim podcast and organizer of the Reversim Summit conference, taking place October. So a few words about gRPC. What is gRPC? By show of hands, who has worked with gRPC? All right, so pretty a lot of you. So we're going to keep it short. So gRPC is a very robust protocol for data exchange. It's built on top of protocol buffers. So you have an IDL, you compile that into different languages. You have several target languages such as C++, Java, of course Go, Node, Python, and so on. What's interesting about gRPC is that it's very flexible and it has quite a lot of features. For example, compression, encryption, pluggable discovery, pluggable load balancing, and a few more other interesting features. So from the client perspective in Go, this is how you connect to a gRPC server. You see a few examples here. So you could, for example, simply dial localhost with port and you get connected to localhost in most cases. You could also use DNS, in which case you might get back a list of several IP addresses, and gRPC would load balance on top of those returned IP addresses. But what's interesting in gRPC is that you have a pluggable discovery mechanism. So for example, in those two last lines, you see that I'm using the console naming scheme. Console is a community-provided discovery plugin for which I've also contributed some code. And what those two lines do is they go to the local console agent and they ask it to return all services that answer to the name of my service. In the second case, also with a few tags. So this is very useful, but also somewhat complex. The means to implement all that is by a mechanism called gRPC-channelz. So let's dive into a little bit of architecture of that. So in very high level, you have gRPC client and gRPC server talking to one another over HTTP2. You could do that in a request-response flow, or you could also do streaming. If we dive into the client, you see something more or less like that. So at the top, you have your own business logic. You have some generated code, also known as stubs, different parts of the stub. Below that, we have the channel API, in which we're going to dive in a little bit. And below that, we have the transport API. The transport itself is based on HTTP2. So now let's dive into the channel API. So the two interesting components there are the pluggable name resolver. So I mentioned console before that, and there are plenty of more pluggable name resolvers out there. And you could also attach a pluggable load balancer. There are a few provided default ones, such as round robin or last used, but you could also implement your own load balancer. And the API is very simple. And if we zoom out a little bit, you see both the client stack and the server stack. And the server stack looks a little bit different because it doesn't need to, for example, load balance. It just accepts connections. But all in all, it's pretty much similar or almost the same. Now, if we zoom in to the transport API layer again, we see that we have channels and we have subchannels and we have sockets. So what's the difference between a channel and a subchannel? So basically, a subchannel is something that's being load balanced on. So for example, you could have one single logical channel and multiple subchannels. Each subchannel represents a single backend server, right? So in the DNS example as before, for example, you do a DNS query, you get back 5 IP addresses. Each subchannel represents a single IP addresses. And the channel as a whole represents the entire service. And the sockets are, well, just sockets. But it gets even more complex. So On those sockets, you have multiple gRPC messages in sort of layered, and it's possible for multiple gRPC. So, for example, a single gRPC server could implement multiple gRPC services, and you could just open a single TCP socket to that server, but send multiple different RPC calls on the same connection. So the entire gRPC system makes that work, and all in all, it's quite complex. Now, this is, as I said, this is quite complex. What happens if, for example, one of the backend services that you wanted to discover does not get discovered? Or what happens if one of the servers misbehaves? Maybe it's flapping, maybe it fails. How do you debug that? How do you diagnose that? And you know, with all good things, there are some bad things. So complexity is definitely one of the things that stand out in gRPC. And one of the ways to solve them is transparency or introspection. So luckily, we have ChannelZ to the rescue. So what is ChannelZ? ChannelZ, and it's okay, you don't need to read this. ChannelZ is actually yet another gRPC service that you expose. And this service has methods such as get top channels, get subchannel, get channel, get socket, etc., etc. So you could use this service to query your own gRPC client or gRPC server. But this is just an API, and it's not that easy to debug a server using just an API. I mean, are you gonna just run CLI and debug things? That's not that. It's not that it's not the happy path. So this is not my work. It's all that existed before I came to this world. And then I decided, okay, I need to provide some more visibility on top of that. Hence, I built a UI layer on top. It was supposed to be an icon. The font didn't work. So I created this project, go-grpc-channelz. So what does go-grpc-channelz does? It exposes a simple HTML interface into the ChannelZ API. So, for example, this is the main page of this component. You embed that HTTP handler into your gRPC server or gRPC client, and you could see, for example, the open channels, their endpoints. You could see the number of sub-channels for each. You can see the number of calls started, calls ended, calls failed, etc., etc. And then you could also click. So for example, let's click on channel 2. And I think what's more interesting here is the log. So you see the log of events down there. This tells you the whole story of this specific channel. When was the socket created? When was the channel created? If there were any failures, you could see them here. So that's very, very insightful. You could also click the sub-channel, and likewise, you could also see the log of events and the current status and the number of calls started and ended. You could click the socket itself, and you could see the events on the socket as well as some options. For example, if you set some security options or other options on the socket, you could see them here. And you could also click the server. In gRPC, there are two sides, right? There's the client side and there's the server side. go-grpc-channelz works for both. It's most interesting for the clients, but it could also work for the server, so that's also very useful. Integration is very simple, just those two lines of code. The first line exposes the gRPC-channelz API, and the second line simply exposes the HTTP handler that I created, and that's it. That's all you need to do in order to expose this UI in your service or in your clients. That's also, to summarize, gRPC is robust and it's mature, and visibility is not optional. Visibility is required, and go-grpc-channelz simply provides what I think is a much needed visibility. So please go ahead, download that, and use it and enjoy. Thank you.